Okay, so let's do another example for solving systems of equations in 3 variables. Again, we have 3 equations, okay? We need to create a chart that has only the coefficients of the variables. Only the coefficients of the variables. So, we have x, y, z, and then a constant. I'm going to make a small chart. Now, I'm only going to copy the coefficients of the variables. So, x has a 2, y has a -1, z has a 2, equals 15. Second equation, x has a -1, y has a 1, z has a 1, equals 3. Third equation, x has a 3, y has a -1, z has a 2, equals 18. We're going to look at each column separately and see, do I have 2 numbers in the same column that are equal with an opposite sign? Again, 2 numbers in the same column that are equal but the opposite signs? Well, we have plenty. We can use this -1 and 1, or we can use this one and -1. So, since I have 1 and -1, -1 and 1, they're equal, which is 1 and 1, and negative sign, this is a positive sign, so they're opposite signs. What we'll end up doing is we're going to add both equations. So, 2 minus 1 is 1, minus 1 plus 1 is 0, 2 plus 1 is 3, 15 plus 3 is 18. That's my new chart. Okay, now let's look again. Do I have any other columns? So I mixed the first and second, I added them together. Can I do the same with the second and third? Yes, because this one and the -1 as well. Okay, they're equal numbers but opposite sides. So let me add both of these equations. I'm going to get 2, 0, 2 plus 1 is 3, 3 plus 18 is 21. Let's look at the new chart. So we have 2 equations. Let's look at each column. Are there any values that are equal with the opposite signs? No, 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 no. Okay, so if we notice here, this is a 3 and this is a 3. So the values are equal, but the signs are different. We need them to be a negative, but we have both of them are positive, and we need this one to be a negative. So what we're going to end up doing is multiply the second equation all by -1. So when we do that, the top equation will stay the same, but the second equation is going to end up being all negative. So -2, -0, 0, -3, -21. Again, you have your x, y, and z. And the number. Okay, so now, looking at the columns, after multiplying the second equation by -1, we created the 3 and the -3. So now let's add both equations up. We have -1, 0, 0, -3. Once you eliminated 2 variables, that means you have 2 zeros. Drop down the letters where they belong. So the first column was x, y, z, and the equal sign. 0 means eliminated. So now I have a new equation that says -1x equals -3. Divide both sides by a -1, x equals 3. Once we find the first variable, we need to look for an equation that has 2 more variables two more unknowns. One of them has to be x. So if I look at this equation, no zeros, so I cannot use any one here. This one has a 0, so we still need x and z, so I can use this one because it has the x and one more unknown. So I will put down my variables, x, y, and z, and I'll write my equation as it is. So I'm using this equation, which is x plus 0y plus 3z equals 18. Then I'm going to plug in 3 for x. So 3 plus 0, so I don't need to write anything here, plus 3z equals 18 minus 3 minus 3, just like solving a linear equation. 3z equals 15, divide by 3, divide by 3, z equals 5. Okay, since now you have x and z, you need to go back to your original equations, and it could be any of these three equations. So I'll choose the second one just because it's easy. So it'll be negative x plus y plus z equals 3. Now I know that x is a 3, so negative 3 plus y plus z is 5 equals 3. Okay, we need to simplify and solve for y. So 5 and negative 3 is just 2 plus y equals 3. Subtract 2 from both sides. Y equals 1. So the answer should be, in parentheses, then you put the values of x, comma y, comma z. It's going to be 3, comma 1, comma 5. And that should be your final answer. Let's do one more question. So again, I'm going to copy my numbers in the chart with x, y, z, and whatever is equal to. Okay. 4, 4, negative 2, 8, 3, negative 5, 3, 0, 2, 2, negative 1, and 4. Okay? So, let's look at each column and see if I have same numbers, different signs. Same numbers, different signs. Do I have any? Of course not. So, since we don't have any numbers that are equal with the opposite sign, then we need to make a number that is equal and opposite sign. So looking at the first and second equation, it's almost hard because there's no relation between the two numbers. Looking at the first and the last equation, we can make the 4 into a 2 by division, but we don't want to deal with division. We need to multiply. So we can multiply the equation by a negative 2 to make this a negative 4. So I'm going to multiply this whole equation by negative 2. So I'll have negative 4, negative 4, 2, and negative 8. So let's add the first and third equation. So we're going to get 4 minus 4 is a 0. 4 minus 4 is another 0. Negative 2 plus 2 is a 0 equals 0. Wow, this is a very good result. It will save us time and energy. So basically what this is saying is, it's saying that 0 is equal to 0. Now you got to think about it. Is this a true statement or false statement? Of course it's true, because 0 will always equal to 0. So in that case, the solution is all real numbers.